Now, I'm going to throw you a curveball. Let's see if you can hit this one. All right. Let's do 35 pi over 12. Okay. Now, let's think about this one. And think what? 12 pi over 12, right? This would be 6 pi over 12. This one would be 18 pi over 12. And so this one would be 24 pi over 12. Now, what do you notice about 35 pi over 12? It goes around the circle more than one time, didn't it? Now, that means, in terms of degrees, that this is more than 360 degrees. So what did we do when it was more than 360? We found a coterminal angle, right, by subtracting 360. Now, we're not going to subtract 360 because 360 is in terms of degrees. So what is radians in terms of 360? 2 pi. And what, 360 is all the way around, isn't it? What's all the way around in radians? 2 pi. So what I need to do is subtract 2 pi, however many times that I need, to get it in between 0 and 24 pi over 12. Okay. Now, let me show you how you can just do this on your calculator. Okay. Now, you don't want to punch in the pi symbol. Okay. What you can do is just use your fraction commands here. So you can use, remember the fraction, the alpha F1? So I'm going to do this. I'm going to say 35 over 12. Now notice that I'm leaving the pi sign off, right? Okay. If I put the pi sign in there, it's going to turn everything into decimals, and I don't want that. So I'm going to say 35 over 12, 35 pi over 12 minus 2 pi. So when I say minus 2 pi, I'm just going to leave off the pi. Does that make sense? So you're going to get there that it's 11 over 12. Now, really, the coterminal angle wouldn't be 11 over 12. It would be 11 pi over 12. So it's just like the ones in degrees. You have to find a coterminal angle. Okay? Now, where is 11 pi over 12 going to fall? Yeah, second quadrant, right there. Okay. All right, what would the, see if this was 11 pi over 12, what would the reference angle be there? Yeah, pi over 12. Minus 2. Okay, so really what you're doing is saying 35 pi over 12 minus 2 pi. You're just leaving out the pi's for the calculator to do it. Yes? Yeah, you could do the same. You could just say minus 24 because 24 pi over 12 would be 2 pi. Okay. Now, if your denominator was different, then you have to do something different there. Okay, but that works. So that's the same thing as subtracting 360. It's to subtract 2 pi. Now, if it was still big, you would subtract 2 pi again. Now, what if this happens to be negative? You would add 2 pi. Okay. Now, let's switch over to some radians here that aren't in terms of pi. Okay. What if I tell you to graph the radian angle 5.75? Now, this is where units are really, really important, because most of the time when people say this, and I tell them it's an angle, they assume it's a degree angle, and it's not. How do I know it's not degrees? There's no degree sign. And so the thing about radians is the only unit in mathematics where you don't have to write out the unit. You don't have to write out radians, it's understood. Okay, so really the decimals aren't that hard. All you have to do is just think of these values in terms of decimals instead of in terms of pi. Okay, so instead of writing the pi symbol, what's a decimal I could write right there? 3.14. Okay, and then what all the way around is 2 pi, and so 2 times that would be 6.28. How could I find out what this decimal value was. Divide it by 2. 3.14 divided by 2 comes out to be 1.57. And then this value would say 3.14 and add 1.57. Okay, let's see, 3.14 plus 1.57 is 4.71. Okay, now can you tell me where 5.75, what quadrant it's going to be in? It's going to be in the fourth. Right, because what the angle that I'm trying to find is in a decimal as opposed in the terms of pi. Okay, so I put all these measures in terms of decimals. Now, 5.75 would be somewhere down here in the fourth quadrant. So it's in the fourth quadrant. Now, this would be the reference angle, wouldn't it? How would we find that reference angle right there? Yeah, just say what, 6.28 minus 5.75. So let's see, that's going to be 0.53 would be my reference angle. Okay, now here again, let me ask you this question. All right, what if it was a negative decimal value? You'd add how much though? 2 pi. So you'd really add 6.28. All right, if it was bigger than 6.28, then you would subtract 6.28, which is 2 pi, to find a coterminal angle. Okay, yeah. What does number 2 say? Pi over 3. Okay, I'll just do it real quick. So I would think of this as 3 pi over 3. She's talking about pi over 3. All right, this would be what, 1.5 pi over 3. So think of this as 1 pi over 3. Where would that be then? That's 1.5, so 1 pi over 3 would be in the first quadrant. Does that make sense? It should be somewhere like that. And since this is in the first quadrant, the reference angle is going to be the same thing. Right. So see, this is the same location. What, 6 pi over 3 just meant I went all the way around to get there. Okay. Since it's in the first quadrant, it would just be the same thing. Okay. So if it's in the first quadrant, the reference angle is the same as the standard position angle. Now, y'all look in your books with me, and we're gonna skip around a little bit because we're gonna go to the next chapter just to pick up one thing about radians. A lot of times, your high school textbook won't introduce radians until another chapter, and I like you to go ahead and start thinking about radians the second day. Okay. Now, so where I want you to look at here, what we're going to learn how to do is how to change degrees to radians and radians to degrees. Okay, on page 344. You grab one behind me. All right, we're going to do 330 degrees to radians in terms of pi. Okay, now if most of the time radians are in pi, I've said that. Occasionally you can just round that. So you just punch in the pi button on your calculator. But let's talk about how would we change degrees to radians, because this is a really important skill, because working with radians, it's a little bit harder to do it. Like if I told you 45 degrees, what quadrant is that in? First quadrant. That's pretty simple. If I told you pi over 4, you couldn't tell me that was the first quadrant. Okay, you would have to figure it out. I know pi over 4 is in the first quadrant because I know where it's at. Okay, because I know that pi over 4 is the same thing as 45 degrees. So let's look at how you can convert them here. Now, the way I convert is I use this conversion ratio. Right here, let's think about that. What was this in terms of radians right there? Pi. And what was it in terms of degrees? 180. Okay, so I wrote earlier that pi radians is equivalent to 180 degrees, and that's the equivalent that we do. So the way I show you this is I use dimensional analysis because your chemistry teachers are really awesome at teaching you guys this. I've noticed that in the past few years, so I switched to this. So I'm going to change 330 degrees to radians. Now, this is the conversion factor that I'm going to use, that there are pi radians in 180 degrees. Now, where would we write 180 degrees, though, in dimensional analysis? Bottom. Because what do we want happen to the degrees? They want to cancel. And so on the top, we would write 1, or we write pi radians. And you don't have to write out radians. Now, what happens to the degree units there? Yeah, they're going to cancel out. Okay, so we're going to get 330 pi over 180. Now, if they didn't tell me to leave it in terms of pi, I would multiply this out on my calculator. So really the only thing that I have to do is take 330 over 180 and reduce it. Now a lot of people could just reduce that in your head. I'm going to show you how to reduce it in your calculator real quick. All you have to do to reduce it is just put it in as a fraction. So I'm going to do the alpha F1 and put 330 over 180 and hit enter, and it'll reduce it for me. So it's 11 over 6. Now notice I didn't push in the pi symbol. If you push in the pi symbol, it's going to give you a big decimal. Okay, so this is just going to, I'm not going to say 11 over 6. I would say 11 pi over 6. So 330 degrees is 11 pi over 6 radians. Because 180 degrees is equivalent to pi radians. See, if I wanted to, if I use 2 pi, then how many degrees would I use down here? 360. Okay, but pi and 180 are the easiest, right? They're the easiest scale factors to use. Okay, now let's go the other way around. Let's take something in radians and change it to degrees. Okay, so let's do 2 pi over 3 radians to degrees. Yeah. Now, a lot of times when you change radians to degrees, usually you can round your answer to a decimal value, especially if this is in terms of pi. Okay. Now, so let's do this. We're going to do 2 pi over 3 radians, and we're going to switch it to degrees. So what do we know about radians and degrees here? There are how many radians and how many degrees? Pi radians in 180 degrees. Now, where would I write pi radians? The bottom. And so then 180 degrees would go at the top. And so the radians cancel. Now, notice what else is going to cancel? The pi's. So really all I'm left with is 2/3 times 180. And notice what my units are going to be. They're going to be in degrees. And you can just throw that in your calculator. Now, that's just going to give you 120. So this would be 120 degrees. Yes. Because 180 degrees is equivalent to pi. So what we're saying here is you can use any conversion factor that you wanted to. Remember how 90 degrees was pi over 2? You could use that. It's just that 180 and pi are the easiest ones, because the other ones would give you like fractions down here. Okay, so you always use this conversion factor. There are 180 degrees in pi radians. Okay, and that's the one you use over and over. Now, let me say one more thing and y'all can back up here. What if this wasn't in terms of pi? Then the pi's would not cancel out and you would have to multiply it out. Does that make sense? If this wasn't in terms of pi, this pi wouldn't cancel, so you would actually have to divide it out. Okay, and there's one in the homework like that that's not in terms of pi, so they won't cancel. Now, you've kind of got a lot to do. You've got a worksheet, and you've got some from the textbook. Okay, but everything is in terms of radians. Right. So you'd add 2 pi. So just take on your calculator, punch in -4/9 plus 2. And that's all you got to do. Now, wait a minute though. That's not bigger than, oh, it's negative. You're right. Go ahead. What'd you get? Negative 4/9 plus 2. All right. Now you should be able to graph that one. Yeah.